In this presentation, we're going to discuss 3 different minorities in mathematics. This is Alan Turing, and this is the Enigma machine. And in 1942, Alan Turing discovered how to decode the Enigma machine.
Alan Matheson Turing was a British mathematician, computer scientist and philosopher, born on the 7th of June 1912. He studied at King's College, Cambridge between 1931 and 1934, earning a first-class honours in maths. Shortly afterward, Turing studied at Princeton University in America, where he found an interest in cryptology. This proved to be one of Turing's most well-known skills. During the Second World War, Turing returned to England and was employed by the British government at the then secretive Bletchley Park. Here, he worked to decipher secret enemy messages and even designed and built a machine to crack the famous Enigma code. This machine enabled the Allies to find out many German secrets and played a huge part in allowing the Allies to win World War II. It is estimated that the discovered information hidden in the codes helped shorten the war by up to 2 years and saved over 14 million lives. In 1954, Turing died from cyanide poisoning, shortly after he was prosecuted for offences that no longer exist. Due to this, in 2013, the Queen granted Alan Turing a pardon and the Prime Minister made an official public apology over the way in which he was treated. And that's Alan Turing.
When doing code making and code breaking, we use a math called modular arithmetic. This will be delved into further on my website. This is Bernard Morin. And this is the process of a sphere version, which he discovered how to do. So what makes Bernard Morin a minority? At the age of 6, Bernard Morin became completely blind. Because of his blindness, his father encouraged him to explore philosophy rather than mathematics. After doing philosophy for a while, he chose to change and study mathematics. Before finishing his PhD, he had already become well known for his work in sphere version. Sphere version seems simple, right? Just cut a slit in it and turn it inside out. And if there were no rules, you would be right. But the problem is we do have rules to abide by. The same rules Bernard Morin had to abide by. Those rules are spheres cannot be punctured, and 2 surfaces can pass through each other, but no creases can occur. We must always have a smooth surface. This is the sphere version that Bernard Morin discovered.
Surprising, but watch this.
Is this it? Is this a sphere turning inside out?
You bet. That wasn't
Although Smale proved the possibility of a sphere version, he did not answer the question of how to do it. He only proved it was possible. Up until Bernard Morin, mathematicians always tried to demonstrate the process through drawing figures, but they were always unsuccessful. Because of Morin's blindness, he chose to use clay models, which led to a breakthrough in the sphere version. In an interview about sphere versions, Morin said, "Our spatial imagination is framed by manipulating objects. You act on objects with your hands, not with your eyes. So being outside or inside is something that is really connected with your actions on objects." This is Katherine Johnson, and she worked at NASA.
I'm gonna be honest with you, Al. When I fly the machine. And right now, it seems like this machine's flying me.
We're on the same page, John. Our guys are on it.
Let's get the girl to check the numbers.
The girl?
Yes, sir.
You mean Catherine?
Yes, sir. The smart one. I mean, she says they're good. I'm ready to go.
All right, we'll get into it.
Roger.
Although this scene isn't completely accurate, Katherine Johnson does remember something similar being said in 1962. As part of the pre-flight checklist, Glenn asked engineers to get the girl, Johnson, to run the same numbers through the same equations that had been programmed into the computer, but by hand on her desktop mechanical calculating machine. If she says they're good, Katherine Johnson remembers the astronaut saying, "Then I'm ready to go." When Katherine Johnson was asked what she believed her greatest contribution to space exploration was, she said, "The calculations that helped sync Project Apollo lunar module with the Lunar Orbiting Command and Service module." In 1939, Dr. John W. Davis selected Katherine Johnson along with two black men to be the first to integrate West Virginia University graduate program. Although Johnson chose not to complete her graduate program, in 1953, she was given the opportunity to work at Langley. My website will go further into the histories of these mathematicians, as well as giving examples and activities to follow to see their work in action.